everyone, welcome to Maths with Mrs. Hammond. This is the second part out of our 4-part series on finding LCM. If you haven't seen the first video, please follow the link at the top. Today's video is going to focus on finding LCM using the prime factorization method. Just before I carry on, please do hit the like button and subscribe to this channel. Finding the LCM using the prime factorization method. First, we need to know what prime factors are, and we'll also need to be able to draw prime factor trees. Now, what are prime numbers or prime factors? A prime number is a whole number greater than 1 with only 2 factors, itself and 1. Examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, and the list goes on and on and on. Now, we're not focusing on prime numbers today, so we're only going to be touching on prime numbers because we need to know what prime numbers are before we could go on to draw prime factor trees and then use the prime factor trees to find our LCM. And when a number isn't prime, because not every number is a prime number, so when a number isn't a prime number, we call it a composite number. And it's worth mentioning here that composite numbers, the word composite means composing, made up of several things. Okay, it's got several numbers in it, right? So what's a prime factor tree? A prime factor tree is a way of expressing the factors of a number, specifically the prime factors of a number. So suffice to say that every composite number can be derived by multiplying a set of prime numbers together. The perfect example using 5, 4 and 20 from our previous video again is the 20 can be derived by multiplying 2 by 2 and 5. Now, as you can see, 2 and 5 are prime numbers, and when you multiply 2 by itself and then multiply that by 5, you're going to get back 20. So 20 is the composite form, whilst 2 times 2 times 5 is the prime factorization for 20. Now, let's now go on to draw our prime factor trees. Now, talking about drawing a prime factor tree, this is not what I'm talking about, right? This isn't a prime factor tree, okay? It's just a tree with numbers on it, but that's not what we're talking about. So we're going to go on to our very first example here. Now let's go on to draw prime factor trees. I'm going to use 24 and 60. Now, the first thing I'd like you to think of are pairs of numbers that multiply together to give 24 and 60. Now, for 24, we've got 1 and 24, but please, when you're drawing a prime factor tree, stay clear of 1 and that number. It's not going to take you far. You just want to stay away from 1. All right. Think of 2 numbers that multiply to give 24, of which one is a prime number. I already have 2 options. I've got 2 and 12. I've got 3 and 8, but because 2 is a smaller number than 3, I will go with 2 and 12. So here I'm going to represent all the prime numbers with the color red, and I'll represent all the composite numbers with the color blue for clarity. So we have 2 and 12, and then 12, of course, can be derived by multiplying 2 by 6. And of course, 6 can be derived by multiplying 2 by 3. So there you have it. That's simply the prime factor tree for 24. So I'm going to do exactly the same with 60. Right. I'm sure you're running through pairs of numbers that multiply to give you 60. But again, I'm going to start with one prime number and a composite number, and I'll think of the smallest prime number that is a factor of 60. Of course, that's 2 and 30. So here goes. So 24 as a product of its prime factors is 2 times 2 times 2 times 3. All right, and 60 as a product of its prime factors is 2 times 2 times 3 times 5. Yeah, so very easy, isn't it? Now let's go on to another example. So pause the video and attempt this question. Now let's have a look at it together. So 18, I'm going to think of 2 numbers. I have 2 and 9, and then 9, of course, is 3 and 3. And 20, I have 2 and 10, and of course 10 is 2 and 5. So it means 18 is 2 times 3 times 3, and 20 is 2 times 2 times 5. Now that we know how to draw prime factor trees, now we need to then take it a step further by finding the LCM using the prime factors we have been able to derive using the prime factor trees. So again, I'm going to draw the prime factor trees for 10 and 12 for a start. Now I'm going to use the prime factorization derived to find the LCM. Now, if you see what's how the numbers have been grouped, I have 10 and 12 on the left hand side, and I have the prime factors. Now, where you have the same number occurring, you align them vertically, and where you have just one prime factor occurring, you align it alone, and you make sure that every form of prime factor has a separate column. Now, if you take a look at the note I have in the grey box here, it says use only one factor from every column. So I'm going to choose one factor from each vertical column. And the second caveat here is where there are two factors, choose just one from a vertical pair. So when I have two occurring twice, I will pick just 1, 2. When I have two occurring ones, then I'm just going to write down 2. When I have 3 occurring ones, I'm going to write down 3. When I have 5 occurring ones, I'm going to write down 5. So there you have it. Now, the LCM of 10 and 12 using the prime factorization method is 2 times 2 times 3 times 5, which gives us 60. So the prime factor of 10 and 12 is 60. Here is your example. Please pause the video and attempt this question. Okay, so we have 9 and 15. First, we need to draw up the prime factor tree to get the prime factors that make up both numbers. Now we need to align the factors on a table like I showed you on the previous video. Feel free to pause the video and go back to the first example. So there you have it. So 9 is 3 times 3, 15 is 3 times 5. When you have two numbers occurring, you choose one from the vertical pair. Now, it's really easy. Now, let's go on to our extension task. We're going to apply the prime factorization method to find the LCM of 3 numbers. Yes, 3 numbers. We're going to do the exact same thing. But first, I'd like you to pause the video, attempt this question yourself, and see how far you go with it. Okay, so the prime factor tree is for numbers 10, 12, and 16. There you go. So prime factor tree is for 10, 12, and 16, and aligning the prime factors. Now, where you have 3 factors, choose just one from the vertical group. So we have 2 occurring 3 times. You have to choose 1, 2. When you have 2 occurring twice, you choose 1, 2. When you have 2 occurring ones, of course you pick 2. And when you have 3 occurring ones, it's going to be 3. When you have 5 occurring ones, you write down 5. Now, the whole idea is you need to pick one out of every single number that occurs, and you'll be able to multiply all these numbers together to get your LCM. That's the end of today's video on finding LCM using the prime factorization method. All right, please remember to hit the like button, subscribe to this channel, and tell your friends about Maths with Mrs. Hammond. Again, if you'd like to see the previous video, finding LCM using the listing method, please click on the link above and you'll get to see the video. Thank you so much for watching. Bye for now.